Hello everyone, I'm Zhonghua Niu again from Yuzhongwan TV, and today I'm gonna talk about one of the very simple and easy way how we can come up with the parameter estimate, which is a loss development factor. And before I do that, I will show you the books that I have published. And original book is from the Casualty Actuarial Society, the exam part 5, the reading materials, estimating unpaid claims using basic techniques. We call it reserving. And I have translated in Korean and add some of my personal experience. You can find it there. And I have a hard copy of it. And later, probably I published it in an ebook and charge a small amount. And also there is for your future reference, there is a basic grade making. And also I translated it into Korean version, rate making in property and casualty. So you can find it later on. And today I'm gonna talk about like how we can get the parameter estimate, which is the loss development factor. And from that exam part 5, estimating unpaid claims based on the fundamental techniques. And there, one given, let's say, the cumulative paid loss triangle and also reported loss triangle. It is not the actual company's data. Probably the author, Friedland, she has come up with her own value, and she tried to use this data to show how all different models, like 8 or 9 models, estimate the future, ultimate loss or IBNR differently. She tried to show us what's the advantage or disadvantage of each individual models, but I put it here, the same data set. And uh, starting point is, like, oh, when you are given this set of data, you have to look at the link ratio, which is an age to age factor, and have a sum of, average, like arithmetic or, geometric or harmonic, and basic chain ladder, which is a volume weighted average. And here you can see some of the discrepancy. For example, like, when you work this one, for example, like shows, like higher and there is a the smaller, decreasing and increasing and up and downs. This one doesn't look good. But anyway, I'll just, like just go ahead with this given data. And I use the most recent 6 years data. For example, I average to this one, but I use the 6 years volume, which is a paid loss amount, as a weighting, right? So that's why I call it volume weighted average, or quite often this says basic chain ladder. I select that, right? Here is upper one. You could choose, like here, most recent 5 or most recent 7 or most recent 8, and it keeps changing based on that. And once you have selected, and this one is, like multiplicative model, right? So it just multiply all the way up to like ultimate, which is 1, right? Otherwise, you have to put the tail factor here, and then that's the same story. But this one, I assume that there is no tail factor there. Anyway, you come up with the loss development factor. In the previous video, I point out that if you reverse it, and that's going to be the payment ratio all the way up to 1, which is very similar to cumulative density function. I just, like copy of it as a value. Later, I'm going to compare it. And if I select this link ratio, that's going to be the basis to calculate the ultimate loss, right? And each development year, I have come up with the like loss development factor, and I have the ultimate paid losses here. And out of this given one, I can create reverse link. So we used to call it reverse engineered. So starting from here, and then I used the selected LDF, and I created the fitted incremental paid loss here, right? And this one is just a simple incremental paid loss from out of this actual data because it is, like the cumulative base. I can just use a simple formula to come up with the incremental paid loss actual data. And by comparing this actual incremental paid loss and pseudo fitted incremental paid loss, I can get the chi-square goodness fit statistics. This formula looks like this. You can find it from loss models of subtitle is from data to decision from Harry Pender or Gold Wilmot. And I just simply take that, sum of it. Or I can have, let's say, some of those, let's say, chi-square goodness fit statistics based on whatever up to development years. And you can do it like this. And most common way in an Excel to change this, selected the link ratio is that here data and there is a goal seek, right? And my criterion is that I want to find the here this one is the one that I want to change to get this target value chi-square goodness fit. It says the difference discrepancy between the observation and expected. Here I would say actual paid incremental actual paid loss versus fitted incremental paid loss. There's difference, right? And this one to minimized. So I set up that way, and it, like runs it, and it does, iterative process to come up with the parameter value that it converges. And here you can find it. I put the, formula on it, but it changes based on the criteria that I have selected. Oh, I pointed out here, I put the restrictions on it, right? Because, like quite often I can define it as the later development value, age to age factor, is not greater than the earlier one. But in the real database, you can sometimes find the bigger age to age factor of the later development than the earlier one because of the recovery or those kind of thing. But here I just assume and put a restriction that the later development, age to age factor shouldn't be bigger than the earlier development. I applied it in a, like chain manner. So like this one, and this one, something like that. That's why you can see it here. But anyway, based on that restriction, it finds this age to age factor selection. The criterion is that the chi-square goodness fit sum of it, that should have the minimum value. That's how it works. And this is the original This one is original and this one is fitted. It looks awkward because, like data doesn't look good. So what it says is that here you can interpret it as the original selection has much faster like claim payment and fitted one has much slower payment pattern, which which doesn't look good. But I'm trying to show you how we can set up the very, like the simple and quick way how we can come up with the like LDF. So don't just think of it, just use whatever the average your selection. It just you put the criteria to get the like the minimum value of chi-square goodness fit. And also using goal seek, you can set up the like the likelihood function that should be based on probably one of the like distribution that you have selected, like log normal, gamma, or Pareto, or sometimes even viable or logistics that you can get the parameter like estimate based on the maximizing the likelihood function. That's the second criterion that I'm going to show you later on in the later video. But here, use the like like minimizing the chi-square goodness fit, which is the discrepancy between the actual and fitted. And there is a very easy and quick way how you can do it. Because the reason I'm showing you is that the stochastic reserving model, even like initial selection of LDF is plays a key role. So you have to understand it and how I can create the sample data to come up with the like parameter uncertainty. So yes, quite often in the statistics you can see that prediction error is composed of, let's say, the estimation error and forecasting error. The first one is, let's say, if I say more detail, when you come up with the, let's say parameter value, there is always an estimation error. And second part, the forecasting error is, regarding on process variance. So when you do forecast, there is another set of, error component. And later I'm going to say detail, but here loss development factor is the starting initial parameter that you can start with. Later, you can move on to the stochastic modeling to estimate the distribution of future like cash outflows, which is a claim outgo. So today, this is it, and it's just a very like a short video that shows you how we can come up with the loss development factor, and you can do it in a reported loss triangle as well. So hopefully, just follow me into the, like actuarial like modeling to validate IFRS 17 results. This is all gonna be the basis for you to understand better how I can show you the actuarial model to validate IFRS 17 measurement estimate. So I hope you enjoy it, and I'll see you in the next video.